Today, we continue our discussion of supply chain information technology, focusing on Chapter 2, Part 2. In Part 1, we discuss the basic framework of supply chain information systems. We examine how information technology supports transaction processing, management control, decision analysis, strategic planning, ERP systems, and enterprise planning. In this section, we move further into the role of communication technology, cloud-based systems, supply chain relationships, uncertainty, and risk mitigation, and blockchain. The central theme is that modern supply chains depend not only on physical movement, but also on reliable information exchange. If materials move but information does not, the supply chain becomes slow, fragmented, and difficult to manage. To begin, let us look at the role of communication technology in supply chain information systems. Communication technology includes the hardware and software that allow information to move within a firm and between supply chain partners. This includes systems used to coordinate inbound materials, production, inventory, customer orders, shipments, and delivery status. In other words, communication technology connects different parts of the supply chain so they can act based on shared information. The key phrase here is real-time information exchange. In older supply chains, information often moves slowly. A supplier might not know about demand changes until much later. A logistics provider might not update delivery status until after a delay had already occurred. A customer might have limited visibility into order status. Modern supply chains require much faster communication. Firms need to know what is happening now, not just what happened last week. Communication technology improves effectiveness because it helps firms meet customer needs. It improves efficiency because it reduces delays, duplication, and unnecessary inventory. It improves relevancy because it allows companies to respond to specific customer requirements. It also supports sustainability by reducing waste and improving coordination. One important area where communication technology has changed supply chains is the direct connection between companies and consumers through the internet. The internet creates a direct interface between firms and consumers. This applies not only to retailers, but also to manufacturers that sell directly to customers. There are two main dimensions of consumer connectivity. The first is ordering. The internet allows two-way interactive communication. Compared with traditional mail order or phone-based ordering, online ordering is faster, more flexible, and more transparent. Customers can check product availability, place orders, receive confirmation, and monitor delivery progress. The second dimension is after-sales service and reverse logistics. After the sale, customers may need to return a product, request a repair, make a warranty claim, or receive a replacement. Internet-based systems allow faster tracking and resolution of these issues. This matters because the supply chain does not end when the customer receives the product. Returns, repairs, replacements, and warranty service are also part of supply chain management. A company with strong after-sale information systems can improve customer satisfaction and reduce the cost of handling service problems. As supply chains have become more connected, firms have also changed how they operate their information systems. This brings us to the shift from traditional in-house systems to cloud-based and hosted systems. Traditionally, especially before the 21st century, firms operated and maintained their own private data centers. They often relied on large mainframe computers and in-house software. This required a major internal commitment to computing infrastructure. Companies needed hardware, software, maintenance, security, backup systems, and specialized IT staff. This approach gave firms direct control, but it also created major challenges. One challenge was high capital costs. Building and maintaining private systems required significant upfront investment. A second challenge was limited scalability. If the company grew quickly or needed more computing capacity, expansion could be expensive and slow. A third challenge was slower updates and innovation. Internal systems could become outdated, and upgrading them required time, money, and organizational effort. Because of these limitations, many firms began moving toward externally hosted and cloud-based systems. The modern trend is a shift toward externally hosted systems, often delivered as software as a service or SaaS. In this model, hardware and software are hosted by specialized providers. Instead of owning and maintaining all computing infrastructure internally, firms access software and data through cloud platforms. This has several benefits. First, organizations can share hardware, software, and technical expertise across multiple users and customers. Second, firms can access state-of-the-art performance without maintaining every system internally. Third, cloud-based systems provide greater flexibility and scalability. A firm can often expand system capacity more easily as business needs change. Fourth, cloud systems may support faster innovation because providers can update features, security, and functionality more frequently. Finally, this approach reduces the internal IT burden and may reduce capital expenditure. For supply chain management, this is particularly important because supply chains often involve many partners. Cloud-based platforms can make it easier for suppliers, logistics providers, manufacturers, and customers to access shared information. Cloud-based systems are not only a technology decision, they also affect how firms build and manage relationships with supply chain partners. This slide introduces 4 related forces that drive supply chain relationships. The first is integrated management and supply chain processes. Firms need to coordinate activities across functions and organizations. Information technology makes this integration possible by connecting systems and data. The second force is responsiveness. Customers expect firms to respond quickly to changes in demand, delivery requirements, product availability, and service needs. Information technology supports responsiveness by providing real-time visibility and faster communication. The third force is financial sophistication. Supply chain decisions have financial consequences. Firms must understand costs, cash flow, working capital, inventory value, and service trade-offs. IT systems help capture and analyze this financial information. The fourth force is globalization. Global supply chains are longer, more complex, and more exposed to risk. Information technology helps firms coordinate across countries, time zones, regulatory systems, and transportation networks. Together, these forces show that supply chain relationships depend heavily on information. It is difficult to collaborate effectively if partners cannot share accurate and timely data. Because global supply chains are complex, information technology also plays a major role in managing uncertainty and risk. A major focus of supply chain information technology is to mitigate risk and uncertainty, improve performance, and reduce costs. The slide identifies several key risks, including material sourcing, quality, reliability, and financial risk. For example, a firm may face risk if raw materials come from an unreliable supplier, if product quality is inconsistent, or if a supplier experiences financial difficulty. The slide also identifies several key uncertainties, such as capacity, visibility, consistency, and tracking. Capacity uncertainty means the firm may not know whether suppliers, factories, or carriers can meet demand. Visibility uncertainty means the firm may not know exactly where inventory or shipments are. Consistency uncertainty means the firm may not know whether quality and service will remain stable. Tracking uncertainty means the firm may lose visibility once a product moves outside direct control. Supply chain information technology reduces risk in several ways. It can help certify raw materials and processes. It can support quality assurance in manufacturing and delivery. It can monitor quality across supply chain activities. It can also support sustainable global financial operations by making transactions and movements more visible. Beyond reducing risk, information technology also reduces uncertainty by improving what firms can see, measure, and predict. Supply chain information technology reduces uncertainty in several ways. First, it provides capacity insights. Firms can better understand production capacity, transportation capacity, warehouse capacity, and supplier capacity. Second, it offers visibility into work in process and in-transit inventory. This allows managers to know where goods are and whether they are moving according to plan. Third, it monitors consistency. For example, information systems can help track whether products are damaged, delayed, exposed to temperature problems, or at risk of perishability. Fourth, it enables full product tracking even when the product is outside the firm's direct control. The outcome is that systems collect and synthesize data, generate risk assessments, and provide recommendations. This can lead to enhanced performance and lower costs. For example, if a system detects a delay in transportation, it may recommend expediting a replacement shipment, rerouting inventory, or notifying the customer proactively. One emerging technology designed to improve transparency, tracking, and trust across supply chain partners is blockchain. Let us now introduce blockchain in the supply chain context. Before blockchain, many firms relied on electronic data interchange, or EDI, to exchange structured business documents electronically. EDI has been very important in supply chain management. It allows firms to exchange purchase orders, invoices, shipment notices, and other standard documents. However, as supply chains become more complex, concerns have increased regarding data accuracy, integrity, and security. For example, if several firms exchange information about product origin, certifications, production processes, or shipment locations, the question becomes, how can everyone trust that the data are accurate and have not been altered? This is where blockchain becomes relevant. Critical areas include material sourcing and certification, production facility tracking, and global product tracking. These are situations where firms need confidence in the history and authenticity of the product. To understand why blockchain may be useful, we first need to understand the challenges it is intended to address. Supply chains face several serious challenges, including counterfeiting, raw material falsification, and theft for resale. These risks are especially high for high-value branded goods, repair parts, healthcare supplies, alcohol, and pharmaceuticals. The pharmaceutical industry is a good example. Pharmaceutical products often have high value and may be relatively easy to falsify. Counterfeit drugs can be profitable for criminals, but extremely dangerous for consumers. Because of these risks, governments have introduced regulations requiring stronger product tracking. In the United States, the Drug Supply Chain Security Act, or DSCSA, requires greater tracking across the drug supply chain. Similar laws exist in other countries. The goal is to track products from raw materials to manufacturing, distribution, retail, and ultimately the patient. This type of environment requires high levels of traceability, data integrity, and trust among many parties. Given these challenges, we now need to define what blockchain actually is. Blockchain is a distributed database that records transactions or events. There are several important characteristics. First, it is tamper-resistant. Data cannot easily be changed or deleted without authorization. Second, multiple parties can access, inspect, or add data. In a supply chain, these parties may include suppliers, manufacturers, distributors, retailers, and logistics providers. Third, no single organization controls the entire chain. This is important because supply chains involve multiple independent organizations, each with its own interests and systems. Fourth, once a block is added, it becomes part of a permanent and immutable record. In other words, the blockchain creates a public or shared information trail. The key concept is trust. Blockchain can help supply chain partners trust the record of what happened, when it happened, and who was involved. Now that we have the definition, let us use a simple analogy to understand how blockchain works. A simple way to think about blockchain is to imagine it as the history of orders or transactions. Each individual order or event can be treated as one block in a chain. Once the block is recorded and added, it becomes part of an unchangeable sequence. For supply chains, the primary benefit is secure and transparent tracking of product movement from manufacture to sale. This can reduce time delays, costs, and human error. Instead of relying on disconnected records held by different companies, partners can refer to a shared record. For example, if a product moves from a supplier to a manufacturer, then to a distributor, then to a retailer, each transfer can be recorded. Later, if there is a quality issue or recall, the firm can trace the product's path more quickly and accurately. With that basic understanding, let us now look at specific ways blockchain can improve supply chain operations. Blockchain has several practical supply chain applications. It can record the quantity and transfer of assets such as pallets, trailers, and containers between partners. It can track purchase orders, change orders, receipts, and shipment notifications. It can assign or verify certifications and properties of physical products. For example, a product may be certified as organic, fair trade, temperature controlled, or compliant with certain safety standards. Blockchain can also link physical goods to serial numbers, barcodes, RFID tags, or other digital identifiers. It can support information sharing about manufacturing, assembly, delivery, and maintenance with suppliers and vendors. An additional impact is serialization. Serialization means assigning unique identifiers to containers, products, or components so that they can be traced individually. This is especially valuable for perishable products, expiring products, or counterfeit susceptible products. For example, in food supply chains, traceability may help firms identify the source of contamination. In pharmaceutical supply chains, traceability may help detect counterfeit or diverted products. These applications create several broader benefits. One major advantage of blockchain is enhanced transparency. Blockchain can document a product's full journey. This helps reveal the true origin of the product and the touch points it has passed through. Transparency can increase trust among supply chain partners and customers. It can also reduce bias or uncertainty in opaque supply chains where information is not easily verified. Blockchain may also help reduce recalls through shared logs. If a problem is detected, firms may be able to identify the affected products more precisely rather than recalling a larger quantity unnecessarily. Another benefit is greater scalability. Blockchain systems can support many participants and access points. This is important because global supply chains may involve large numbers of suppliers, carriers, processors, distributors, retailers, and regulators. The next benefits of blockchain are security, innovation, and the overall supply chain outcome. Another major advantage is better security. Blockchain uses a shared, indelible ledger with codified rules. Because records are difficult to alter, blockchain may reduce the need for some internal audits or manual verification processes. Another benefit is increased innovation. Because blockchain has a decentralized architecture, it can support new specialized applications. Different firms or industries may develop blockchain-based tools for certification, tracking, compliance, payment, or product authentication. The overall outcome is that blockchain provides a secure and immutable foundation for trust, efficiency, and risk reduction in global supply chains. This is especially important for high-value and regulated products, where authenticity, safety, and traceability are critical. However, it is also important to recognize that blockchain is not a magic solution. It is most useful when the data entered into the system are accurate and when partners agree on standards, access, and governance. After discussing blockchain as an advanced technology, let us return to the broader picture of supply chain information systems and how they enable the modern supply chain. The ERP system is described as the backbone. It contains the data warehouse and executes core transactions such as order entry, inventory receipts, and shipping. The key requirements are data integrity, consistency, and transparency. Data integrity means the data are accurate and reliable. Consistency means different parts of the organization are working from the same information. Transparency means relevant users can see the information they need to coordinate decisions. The transaction system must also deliver security, flexibility, and speed. Security is necessary because supply chain systems include sensitive information about orders, customers, suppliers, prices, inventory, and financial transactions. Flexibility is needed because supply chains change over time. Speed is necessary because modern supply chains require fast decisions and fast execution. Once the ERP backbone is in place, the organization can build supply chain operations and planning capabilities on top of it. Supply chain operations require transaction capabilities that support several key areas. These include customer relationship management, logistics, manufacturing, purchasing, and inventory deployment. These areas represent the operational core of the supply chain. They determine how customer demand is captured, how goods are made or sourced, how inventory is placed, how products are moved, and how orders are fulfilled. The slide also emphasizes enterprise planning and monitoring. Enterprise planning supports balanced decision-making. For example, firms must consider trade-offs among forecast accuracy, production costs, and inventory carrying costs. If a firm produces too much, inventory carrying costs may increase. If it produces too little, service may suffer. If the forecast is inaccurate, both cost and service can be affected. Enterprise monitoring provides real-time visibility and event management. It tracks inventory movement and alerts managers to disruptions such as weather, congestion, or delays. This allows firms to be proactive rather than purely reactive. The final point pulls everything together by emphasizing communication and advanced technologies. Communication and advanced technologies enable secure and accurate exchange of order and inventory information across the entire supply chain. This includes traditional communication systems, cloud platforms, visibility tools, and blockchain for enhanced trust and traceability. The final takeaway is that supply chain information systems serve as both the backbone and the nervous system of the modern supply chain. They are the backbone because they provide structured data and transaction processing. They are the nervous system because they provide real-time coordination, visibility, alerts, and communication. Without these systems, modern supply chains will be slower, less accurate, less responsive, and more vulnerable to disruption. So, the main message of this section is that supply chain information technology is essential for efficiency, responsiveness, risk management, and competitive advantage in today's global supply chains. This concludes Chapter 2, Part 2. In the next part of the course, we will continue connecting these information systems to broader supply chain planning, execution, and performance management. At this point, students should understand that supply chain information technology is not simply a technical support tool. It is a core capability that allows modern supply chains to coordinate activities, reduce uncertainty, improve visibility, support collaboration, and manage risk. As you review this chapter, focus on 3 key ideas. First, information technology enables real-time coordination across supply chain partners. Second, cloud-based systems and communication technologies make supply chain collaboration more scalable and flexible. Third, blockchain and related technologies can improve traceability, trust, and transparency, especially in high-risk or highly regulated supply chains.